You ever look at code and think it's some kind of complex alien language? Well, what if I told you that you're already using its core logic, like every single day? Today, we're going to pull back the curtain on the basic building blocks of programming, and you'll see it's way more like following a recipe than you might think.
So at its absolute heart, a computer program is just a list of instructions. Seriously, that's it. Kind of like a recipe, right? It just starts at the top and goes straight down, one step at a time. Add the flour, then add the sugar, then mix. Super simple, totally linear. But let's be real, life is rarely that straightforward, and neither are the programs we actually use. I mean, what happens if the recipe needs a choice? Like, maybe you only add extra sugar if the bananas aren't very ripe. Or what if you have to stir the batter exactly 50 times? A simple top-to-bottom list just falls apart. It can't handle that stuff. For our program to be actually useful, it needs to be able to make decisions and, repeat things.
Okay, so here's the game plan. First, we'll look at that simple, straight road of a program. Then we'll introduce some crossroads using something called if-else. After that, we'll see how to repeat a step with a while loop, and then how to do it a fixed number of times with a for loop. And finally, we'll put it all together to see how you can create some really smart paths.
Right, so let's start with this idea of a straight road. This is the most basic kind of logic. Without any way to make decisions, a program is just stuck. It's on this one, single, unchangeable path. It'll do the exact same thing every single time. Which, okay, might be fine for a super simple calculator, but for pretty much anything else, not so great.
So, to break free from that boring straight line, we need our very first tool. Think of it as a crossroads. In the world of programming, we call this an if-else statement. And this is the fundamental way a program stops just following orders and starts, thinking. It can look at a situation and actually choose which path to take.
And here's a perfect everyday example. You're about to leave the house. You look outside and ask a question. If it's raining, you go down one path. You grab an umbrella. Else, meaning if it's not raining, you go down a different path and grab your sunglasses. See, it's a simple question that leads to one of two very different actions. And that's really all we're doing when we talk about this in code. The if-else statement is just the official programmer's way of writing that down. It tests a condition, and depending on whether the answer is true or false, it sends the program down one of two totally separate, exclusive roads.
Okay, let's see this in action. Imagine a program that's grading an exam. The whole thing hinges on one question. Is the score 50 or higher? If the answer is true, the program takes path A, and boom, you get a congratulations message. But if it's false, it's forced down path B and tells you, sorry, you didn't pass. Two completely different outcomes based on one simple check.
And this isn't just for, school grades. This logic is everywhere. Think about it. Checking if your password is correct. That's an if-else. Applying a discount if your shopping cart is over $100. Yep, if-else. It's even used to catch errors before they crash an app. It is the absolute workhorse of making decisions in code.
All right, so now we can choose a path. That's a huge step. But what if we need to do something over and over and over again? For that, we need our next tool. It's called a while loop, and it's perfect for when you need to repeat an action, but you don't know exactly when you're supposed to stop. Here's a great way to picture it. You're walking somewhere, trying to find a landmark. Before every few steps, you pull out your map and ask, am I there yet? And while the answer is no, you just keep walking. The repetition, the walking, it all depends on that one condition.
So the official definition is pretty much what we just said. The key idea here is it repeats as long as a condition is true. And this part's really important. Just like you check your map before you take another step, the program checks the condition before it does anything. So if the condition is false right from the get-go, the loop never even runs, not once.
Okay, let's walk through this super simple counter. We start a counter at 1. The program asks, is 1 less than or equal to 5? Yep, it sure is. So it shows the number 1 on the screen. And then, and this is the critical part, it adds 1 to the counter. So now it's 2. The program loops back. Is 2 less than or equal to 5? Yes. It just keeps doing that until the counter hits 6. Then it asks the question again. The answer is nope, and the loop finally stops.
But what about when you know exactly how many times you need to do something? You don't need to keep checking a map for a landmark. You just need to, say, take exactly 10 steps. Well, for that, we've got an even more specialized tool, the for loop.
This is just like a workout routine. If the plan says do 10 push-ups, you do 10 push-ups, not 9, not 11. The number is fixed from the very beginning. You know where to start, where to end, and how to count.
And the for loop is built for exactly that kind of predictable, set-in-stone repetition.
The real power of the for loop is just how neat and tidy it is. It bundles everything you need, the starting point, the stopping point, and how to get from one to the other, all into one clean line. It's just designed to be super clear whenever you know exactly how many times you need to loop.
So where would you use this? Oh man, everywhere. It's perfect for going through every single item in your shopping list one by one, or for processing every pixel in a digital photo, or maybe running a simulation for exactly 100 turns. Basically, if you know the number up front, the for loop is almost always the right tool for the job.
All right, let's just take a step back for a second and look at what we've put together. We've gone from a simple, kind of dumb, straight road to a dynamic system that can actually make choices and repeat actions. These things we've talked about, they are the absolute foundation of pretty much every intelligent program out there.
So really it all boils down to this simple toolkit you now have. When you need your program to make a decision, you reach for the if-else crossroads. When you need to repeat something but you're not sure when to stop, you use the repeat until while loop. And when you know exactly how many times to repeat, that's when you grab the fixed number for loop. See, these aren't just a bunch of abstract rules. They're tools for creating something. They're what let you design logic, solve really cool problems, and build something that can actually respond intelligently to the world around it. So the only real question left is, now that you have the map and the tools to choose any direction, what path are you going to create?